Good evening, everyone. This is the first, as you probably know, this is the first of a series of 3 evening programs, interconnected lecture discussion programs on the general issue of global climate change and our responsibility for it and what we're going to do about it. I'm here representing the local chapter, the Montana chapter of the United Nations Association, which is a private organization, a membership organization, a nonprofit educational organization that has as its main goal to inform the American public about what's going on in the global regime to which we pay such a little attention, and in particular, the interrelationship between our government in Washington and the other governments that it relates to, in either for better or for worse, through international bodies like the United Nations. The UN Association was actually founded with a slightly different name right after the Second World War. And the first president was Eleanor Roosevelt. And the UN Association was created by FDR because he was afraid that the same thing would happen to his new UN, which, by the way, was created in the State Department of the United States over a period of 2 years during the war. But he was afraid that it might go the way of the League of Nations with the United States not joining. In fact, it met with a great enthusiasm in the beginning. Everyone thought perhaps that we had found a way to solve international disputes without wars, and everyone was heartily sick of war. But, of course, the last 60 years of its existence have demonstrated that things don't quite go the way you hope they will. And I think in the Cold War period, there was a great deal of disillusionment. It seems possible that now that things have changed from the Cold War, there is an opportunity, a real opportunity, to move forward into civil solution of international problems through such agencies as the UN. The program series is called The People Speak, and this is a program that was put together. It's a national program. Programs like this are held in towns and cities all around the country with literally tens of thousands of people participating. And the general theme this year is the relationship between the U.S. and the UN. But beyond that, the themes that are chosen locally. And of course, we have chosen a theme of the relationship between the emission of greenhouse gases, and the effect that has, or what the scientists believe it has, on the changing climate. That's Steve Running's talk tonight. Then on Monday, we come to the question, okay, so if we agree that at least with enough probability that we ought to really be doing something about this, that if the issue is not do we do something, but it's when we do it and how we do it and what we do, if that's the case, then we come to the next talk, which is on Monday evening. Our speaker then is a physics professor from Colorado named Jack Kraushaar. Interesting enough, Jack, who's retired now, did the first version of his book. He's co-author of a book on energy and the natural environment, and that was created as a result of the first energy crisis back in 1973. And there have been upgrades on the book since, and in fact, just by chance, the latest edition with all of the latest information is in press right now and should be out in December or January. And then in the third session, we will turn to questions of policy. What, in fact, do we do? And there will be two speakers. I have the job of trying to explain the political situation in the United States, the different players in the game, the positions they are taking, the interrelationship between the U.S. and the countries of the European Union, Britain, Japan, and so on, the differences among these positions, and sort of laying out why we are, I suppose, and have been trapped in a period of nothing happening, a frozen period for a number of years. And the question is, can we get out of that? Can we bring the players together and find a compromise way of moving ahead? So that's what the long haul program is about. By the way, the creator of the People Speak series is another organization called the UN Foundation. And that is the foundation created by Ted Turner when he decided to give $1 billion to the UN. He found he couldn't give it directly to the UN, so he gives it to many organizations. UN Association is one, that are working to make the UN function better than it has been able to in the past. So that brings us to this evening. This evening's speaker, everybody here probably knows Steve Running. And my wife says, well, she's heard him twice this fall, but she's here again, I see.
Oh, no.
And in fact, Steve tells me that really things are developing very rapidly. New information is coming in. I've been talking to other people who are involved in this IPCC, the International, or the Intergovernmental Panel on Climate Change, which is an alliance of literally thousands of scientists in all kinds of fields around the world who have been working for the past 15 or 20 years in trying to get the answers as to what is happening, to what extent are we responsible for the fact that it's happening, and what can we do about it. Steve's been involved in that for how long, would you say, have you been involved in that?
Oh, I've just been the last 2 years.
Only for a couple of years.
Yeah, I got the rest for a while.
But on the other hand, you've been involved in trying to examine the relationship between the how the climate is changing the biota of the planet, and that specifically is the area that with using satellite Landsat projections down to the Earth, looking at the spectrum that comes up and figuring out what that means on the Earth, on the surface of the Earth, which is one important piece of the whole puzzle. And Steve will be the lead author on a book that's coming out. I guess it's in about a year that the whole next session from IPCC is coming out, and there's going to be a lot in that. And so everybody who's doing that is working very hard, and will be for the next many months, to bring it about. So we're pretty lucky that Steve is in town and is willing to give that talk tonight before he rushes off to the far corners. And so I give you Steve Running.
Before I start, how many of you have heard this talk before? Oh, not quite as many as I thought. I thought if they've all heard it before, I can't tell the same old stupid jokes. I have to think of new ones. No, I will say that there is some new material in here that I put in 2 days ago. So even if you've heard it before, you haven't heard all of it. Yeah, okay, there you go. And that should be it. Yeah, so I can't remember when I first started giving this talk. It's something like 5 or 6 years ago. And to tell you the truth, it's getting easier and easier to give because there's more and more material to work with. And I think the other talks you have next week are going to be the hard job of what and when are we going to start doing something. My job tonight really is just to, in much the same way that the IPCC report is tasked, my task tonight is just simply to show you the facts. And so I don't, I'll stick right to the facts, and there's lots of them. And I do have a problem that this talk keeps getting longer and longer, and I have to take a few things out or else I'll kill the audience. And so let's start with some of the original statements. The IPCC, the third assessment came out in 2000. We're writing the fourth assessment now that's due out in April of 07. And this one sentence was the one that was quoted most widely in all the newspapers, that the Earth's climate system has demonstrably changed on global and regional scales, and at least some of this change is attributable to human activities. Now, of course, that sentence was written something like 6 years ago. And so the American Geophysical Union had a statement 3 years later. Human activities are increasingly altering the Earth's climate, and that is a couple years old. So what I'll show you tonight is really the latest. Now, this all starts with in our first inkling that something might be up. Started with Charles David Keeling's Mauna Loa CO2 record, and he started that in 1957, and they've been able to extrapolate back before then from ice core bubbles to see what the background CO2 concentration globally was. And the minute he started measuring the trajectory, within 3 years he could see two things. Number one, seemed to always go up, and number two, there was this clear seasonal cycle of in the wintertime the CO2 would be higher, and in the summertime, as plant photosynthesis sucked up CO2, it would be lower. So there'd be a seasonal cycle, and yet the trajectory was continuously up, and as you can see, there hasn't been 1 year that it's ever gone down since the measurement started. Now, the principle of greenhouse gas trapping heat and warming the Earth was actually hypothesized over 100 years ago. And so this was really some very basic physics about how the CO2 molecule operates in what we now call a greenhouse gas effect, that it allows shortwave radiation to penetrate through the atmosphere, but long-wave radiation it traps as it attempts to be reflected back out. And so this basic physics is really, as I say, well known, not a surprise at all. And this concept that the Earth might heat up with industrial emissions is almost 100 years old. So let me start by looking at just some of the basic climate numbers. And the one you typically see is the global annual mean temperature, which has gone up in the last 50 years on the order of temperature anomaly, a couple of degrees overall. We find that the global annual mean temperature is probably the least interesting thing to look at, and yet it's what's quoted the most commonly. Looking a little more specifically, and this slide shows that all around the U.S., except for a bit of the southeast, the temperature trend over the entire century has been up by something like a degree for the continental U.S. precipitation has also gone up. And this is one of the things my personal research is trying to understand is the water balance actually getting drier or wetter in the landscape? Because we know over the 100 years that precipitation has gone up pretty uniformly, and this also is expected by basic theory that as you warm the ocean waters, you get more evaporation, and that evaporated water turns to clouds over the land surface and rains more. So both of these are expected results from physical theory of climate. Now, one of the things I do in this talk is I don't show computer model results. I really want people to see direct measurements. And so I'm cheating only on the next two slides. They're the only slides that talk about computer models. And this is global climate model analysis of human attribution. And basically, the way they test these models is to first see if they can represent past climates correctly. And so you see that this is the model result over the last 150 years. And what we really look at is to see if it represents the normal range of variability. You don't expect it to get every day right or every location, but does it fit in the normal range of variability? And the answer is it certainly was until about 1980. And as they ran the model forward from 1980, it continued this trajectory, whereas the observations started up like this. And the only way they were able to match these observations were to add greenhouse gases and sulfate aerosols to the model. And so this is probably some of our clearest attribution of the warming trend of the Earth to specific greenhouse gas production. It's very hard to really make that clear, what should I say, to clearly be able to make that causality, and this is about the best we can do. Now this just I find to be an incredible picture, and because this is aircraft contrails in January from satellite over the southeast U.S., and it just gets you thinking about how much not only CO2 but how much in the way of aerosol loading that we put in the atmosphere from just this one aspect of our economy, commercial airline traffic. And in fact, after September 11th, this was one of the best atmospheric experiments we ever had. For what, about 3 days, commercial air traffic was grounded. Meteorologists could detect the difference in the atmosphere within 1 day. It was a measurable clearing of the atmosphere 1 day after the aircraft were grounded. And so that is such a continuous loading of aerosols in the atmosphere that our airline traffic alone is changing the climate. All right, let's take a look at some responses of these basic climate trends. And to start with, we have to think about the ocean and talk about ocean circulation. And when I was in graduate school, they didn't have any of this figured out. And so this really is Earth system science of the last 20 or 30 years, how the global oceans on multi-hundred-year time scales slowly circulate around the planet. Well, what we've seen is the global oceans have warmed up all around the world. And so you look at temperature in the different oceans here, from the South Pacific over here to the North Atlantic. Every single ocean has warmed up. And this is a compilation of millions and millions and millions of ship records. And this was, these data first started coming out about 2 years ago, and have been some of the really key measurements of global warming. And since I'm a terrestrial scientist, I really had to work on this myself to understand it. And I finally, this one paper came out in 2001, and I finally got it. And the punchline, to save you all the misery, is right here. What percent of the global heat balance is in different parts of the Earth system? Is it in sea ice or mountain glaciers or the atmosphere? All the heat content is in the ocean. And this really helps us understand that to do a 5-day weather forecast that we see on TV every night, you watch the atmosphere. The air that's going to be here about next Tuesday is over in Siberia right now. So they track the atmosphere to follow weather. But if you want to understand climate, multi-year climate, you have to follow the oceans. And that graph there is why. I pushed this material to the top because I think this is the most significant new evidence that we've got. We've all, in the last few weeks, been watching about the hurricanes on the Gulf Coast, and Katrina going through New Orleans, and we've all read that this was the most active hurricane season in history. And it started coming up pretty quickly. Well, gee, could this be the result of global warming, or is this just kind of random bad luck on the part of humanity? Well, it turns out there's been if I would have answered that question, in fact, I used to address this. I've always addressed this in this talk. And a year ago, I said, no, there doesn't seem to be any evidence that hurricane frequencies or intensities are at all connected to global warming. Science has now changed its mind in the last 2 months. And here are the two graphs that show it. The first is a paper that was in Nature on the 4th of August by a professor at MIT, where he computed what he called the potential destructiveness index. And when you're talking about hurricanes, there's a variety of attributes that matter. And top wind speed is only one of them. That's what they talk about on the TV every night, but that actually isn't the ultimate metric of how powerful a hurricane is. It involves sustained wind speeds, it involves the size of the hurricane itself, the movement rate of the hurricane, its duration over any given spot. I mean, you can think through, in principle, that those are all the things that would add up to how much punishment can this hurricane deliver. And that's what this destructiveness index that he computed looks like. And this is for the Atlantic and Pacific. The solid line and the dotted line are the sea surface temperatures. And so this is the first paper that, as I'm aware, has ever been published that clearly showed that the upward trajectory of ocean temperatures that I just showed you in the last couple slides correlates quite ominously with the power of these hurricanes in both the Atlantic and the Pacific over the last 40 years. And the minute this paper came out, my email exploded. That's how significant this was. And it was followed not 5 weeks later by another paper, by a whole other group with a different type of analysis and the same conclusion. And this is significant. What this group found, and this is Webster et al. In Science on September 16th, and this is a guy at Georgia Tech, and I was at Georgia Tech and heard him give this talk just 3 weeks ago, so that was pretty cool. What they found, that what is changing are Category 4 and 5 hurricanes. And then notice this is time since 1970 in 5-year increments, And they're finding overall that category 1 through 3 frequency hurricanes aren't really changing any. But what appear to be changing dramatically are the number of the big ones. And so we put these two papers together that both came out within the last few weeks, and recognized both these papers came out were written before this hurricane season. So they don't even have the biggest season in history in their data set. And yet they're still showing 30 to 40 year trends of progressive hurricane intensity. This has been, this last month in climate change science has, in the science community, has been inordinately active in discussion because of these two papers. I mean, these are not just a couple of more papers to add to the stack, we'll have to stick them in the report. These are significant new findings of a connection between warming trends and a serious natural hazard that had never been put together before. And so this has been quite an active month. And remember, what is driving this hurricane strength are the progressively rising sea surface temperatures. And the ocean temperatures get amazingly hot to a Montanan, and it's just unbelievable how hot. You've got 85-degree water down there in the Gulf and things like that. And what particularly we find interesting, and this was in the last, I'm starting to lose track of which hurricane it was, the one that went from a category 1 to a category 5 in something like 26 hours. They'd never seen anything like that before. How could it go from a 1 to a 5 in 1 day flat? If I lived on the Gulf Coast, I'd be nervous. I really would. Because it's one thing to talk about climate change kind of slowly developing over a century. It's another thing to show two different analyses that show the potential that if they thought this year is bad, we're going to have lots of years like this in the next half a century. All right, some of the older stuff. I figured I better put the newest stuff right up to the front, and partly because I think it's now the most significant. But now look at some of the older, and by older I mean it's 2 years old instead of 2 weeks old. We've known for a long time that the polar ice caps are getting thinner. And this one paper that came out about 4 years ago was based on the naval nuclear submarine measurements. When they first started having the nuclear subs go up under the ice, they needed to know how thick the ice was so they could surface periodically. And I used to try this test, but too many of you have heard the test of how thick the ice is at the North Pole, so somebody cheat. But typically when I give this test to an audience, people would guess, oh, it's probably 100 feet thick, 200 feet thick. I mean, this is the North Pole. Well, the average ice thickness at the North Pole used to be about 9 feet thick. It's now, in the last 45 years, shrunk by about 4 feet, 1.3 meters. So it's now about 5 feet thick. So in 40 years, we've lost something like 40% of the ice thickness of the Arctic ice cap. And some of the newest satellite data you can start seeing spatially, where all around the Arctic Ocean here, some of the melt margins. That this is something we can measure really well by satellite. And so of the different measurements we have, and in fact, yeah, this is the total Arctic ice cover since 1978, when this satellite went up that measures, it's a passive microwave sensor that measures just simple ice extent. And you see a trajectory down that comes up to about the area of Montana every decade being lost over these last 25 years. So we've now lost something like 2.5 to 3 Montanas of ice cover in the Arctic. This is another graph, a little older but clearer graph that shows the trend line for sea ice. The glaciers. We know that the glaciers are retreating in Glacier Park, and this is what all the glaciers in the last 50 years in Alaska, maybe not quite all of them. There's a few that are expanding, but clearly the vast majority of these glaciers are the mass, which is the length, the width, and the depth computed together. Those are shrinking. In Antarctica, the same situation. That back in the 40s, they appeared to be increasing, and for the last 30 years, the net glacial balance in the Antarctic has been progressively down. A couple of pictures so we aren't just looking at graphs all night long. The South Fork of the Cascade Glacier in 1928 and now in 2000. And so this is there in North Cascades National Park. And then of course our own Grinnell Glacier here, you can see barely the outline of the older years ago, like 100 years ago, where this glacier was, 1993, and of course now it's down even farther. What my friend that's the global change scientist at Glacier says they expect there to be no glaciers by 2035 is their current projection. They'll be all gone. You'll see there's a lot of cryospheric information because snow and ice is something that we can measure better than a lot of other things, particularly by satellite. This is a look at permafrost depth in Fairbanks. And so my whole point here is to show you a variety of very different types of information, not just temperatures over and over. And you see that in the last 50 years, the permafrost temperature would be minus 2 degrees, minus 1 degree. Now it's getting to the point where, and this graph is getting to be a little bit old, the permafrost is thawing in the summer. And there's houses that have had to be abandoned in Fairbanks already because they used to use permafrost as a free foundation. And it just build houses on the ice. And now that the ice is melting out from under the houses, my friends took me to buy a couple of houses that are just all askew. That part of it just melted out and the house is all crooked and is abandoned. It's unlivable. And so clearly in Alaska, nobody has to come to lectures like this to tell you the truth. It's obvious to all of them. This is a compilation of the ice update of the major rivers and then the melt out date. That's not the right term. The breakup date for a whole bunch of rivers. McKenzie, Mendota, these are all over the place. McCall. And the trend of every one of these, some much more than others, is that they freeze up on the order of a couple of weeks later nowadays, and they're thawing on the order of 3 to 4 to a few of them 5 weeks earlier than they did. These go back a good long ways. These are the kind of records that are particularly interesting for climate science is we didn't have very many good instruments back in 1845. But one of the things they did measure really carefully for commercial reasons was just when the rivers froze up. And so these kind of historical reanalyses of climate relevant measurements have turned out to be really useful, and this river and lake ice are a good example of that. And they measured all over the world, as you can see. Okay, getting off the cryosphere for a while and talk about something else, sea level. And sea level has been increasing on the order of, I think, on average they figure about a foot in the last century. And with one exception, and that could be rebounding of the land surface after glaciation. The land, I think the land here in the Rockies is still rebounding from glaciation 10,000 years ago. And so that's probably what makes Sitka, Alaska, since it's the only far northern one of these, something like a foot of increase in sea level. And most of this rise is not due to more water. It's due to just thermal expansion of water as it gets warmer. And so as the oceans continue to warm, apart from polar ice cap melting and glacial melting that are occurring, we're going to get sea level rise purely because of thermal expansion of the warming water. Are floods increasing? Part of the theory of global warming is an intensification of the hydrologic cycle. More evaporation, more clouds, then more rainfall. That's a hypothesis that continually is trying to be tested. That was part of the hurricane hypothesis. Is there any evidence for more intense storms? And as I say, until 2 months ago there wasn't, and now it appears there is. For flooding, this is a little bit convoluted. It's the percent of the U.S. that have had a higher proportion of annual precip in one-day extreme events. In other words, when it does rain, is it starting to rain harder more often, is the best way to describe this. And you can see that since the turn of the century, there's been a slow but measurable trajectory of stronger rainfall events overall. Not, it's going from something like 10% to something like 12%. But it does appear that there is some evidence that we're getting more intense precipitation. Let's look at biospheric responses for a while. And this is, now phenology is kind of one of my favorite little pet topics in climate science, because it's probably the most observable connection between the climate and plant communities. We can really see in the spring when the buds burst. And when we have a cold spring, it takes a couple of more weeks before they burst. And that is directly a climate-sensitive plant process. Well, people have measured simple bud burst around the world for a long time. And this particular data set was for aspen up in Edmonton. They started way in 1900 and took it for a few years and then got bored, and then I guess decided it might be pretty interesting to pick it back up again. What we see, the overall trajectory of this is for bud burst coming a couple of weeks earlier than it did 100 years ago. Spring comes earlier. Same sort of thing we found. This is some work of my lab computing the growing season length from climate records and stations around Alaska. In the last 50 years, they've gained a couple of weeks, about 14, I think it's almost 14 days in this 50 years of frost-free growing season length in all these stations combined. A paper that came out in the Bulletin of the American Meteorological Society that computed the frost-free day length, the frost-free days, the continuous frost-free days over the last 50 years. The whole western U.S. is showing statistically significant increase in the number of frost-free days. This is good news for gardeners. And in fact, I look at this, and when I first moved here in 1979, I planted an apricot tree. And it didn't make it very many years, but I'm going to plant another one, because I think maybe it'll make it now. We've gained, according to this record, about 2 days per decade. So about 10 or 12 days. We really don't know what to make of the West Coast. I mean, that's basically 5 days per decade for 5 decades. That's 25 days longer frost-free period in those western states. That's quite remarkable. One of the benefits of the longer growing season length is that overall we think that the terrestrial primary productivity is getting higher. So the plants, maybe we shouldn't be surprised, plants like greenhouses, and plants seem to like the global greenhouse too. Overall, we see an increase of about 6% in global NPP in the last about 20 years. Those warmer temperatures aren't such good news for coral reefs, though. And I'm no expert on coral reefs, but what they tell me is that they really bleach out pretty abruptly when they exceed temperatures of 85 degrees in the water. And these are all the reefs around the world that have measured those sort of thresholds of temperature and have observed bleaching. And so this isn't quite as strong of evidence as some of our other material. This probably wouldn't make the cut in the IPCC chapter, but it certainly is enough that it's being watched very carefully by the oceanographers. And unlike the land surface that we think the primary production is going up, most of the oceans in the last 20 years have had their primary production go down. And remember, primary production is just a technical term for plant growth. And so the plant growth of the ocean appears to be going down, with the exception of the Indian Ocean, are these two that are up a bit. Probably the topic, along with hurricanes and natural hazards, probably the other topic that global change scientists shudder to think about the most is human health impacts. Is it possible that climatic change trends could trigger some sort of big global health crisis? And of course, bird flu is what we're hearing about right now. It's outside my field, so I don't have any real expertise in it, but I watched this intensely because if it was ever documented a clear connection between global warming and some really substantial human health hazard, I think maybe even George Bush would wake up. That would be a significance that would really be quite hard to ignore. So far, I've not seen definitive evidence that there's a climate change causality to any human health issue. There's lots of human health issues, and bird flu is the latest, but we can't connect climate to that so far. And so this is one we're sure keeping a very close eye on, but probably because there's so many other factors that control the human health issues, we may be a long time before we could ever isolate a climate signal to their patterns. And particularly with things like the bird flu, it sure makes you not want to get on an airplane. Because everything I read now is any little epidemic that might start off over there in Thailand or something could circle the world in less than 2 days. If just one wrong person got on an airplane and went from Bangkok to Los Angeles, and that's the part that really scares the global epidemiologists, is that the global air traffic would spread any epidemic way faster than anything that's we've ever had any experience with. And it literally could go around the world in hours, not even days. But I repeat, I have never seen a paper that definitively can blame climate change for any of these new epidemics. All right, let's look at Missoula directly. Yep, it's warming up here also, about 0.4 of a degree per decade. But this is the one that really spun us for a loop. Our March temperatures have gone up 7 degrees. I'm sorry I don't buy season's tickets at Snow Bowl anymore. And that's why, right there. Too many years. And last year was a perfect example of it. We seem to be having a pretty normal snowpack all through the year, and all of a sudden on about March 6th, it was just gone in 4 days. I remember getting up there one last time on something like March 11th, and I was walking on mud. And so we're seeing this progressively, that even our winters that seem pretty normal in winter snowfall end awful darn early. The good news of that is it costs less to heat your house. It's about 10% less heating degree days than it was 50 years ago. I think the old timers were right when they said it was a lot tougher when they were kids. It really was. Our trends in snowfall here, we're down about 1 foot in the last 50 years. Right down here in Missoula, of course, this is the kind of trend that basically made Marshall a non-viable ski area because it was at the lower edge of the snow range, and then as the snow fall gets lower and lower, they just can't sustain a long enough season. This is the gardener's favorite graph, that right here in Missoula, the same as that national trend I showed you a few minutes ago. Our frost-free days have extended about 2 weeks. When did we get our first killing frost here this fall? Yeah, it was about 4 days ago. It was November. I had flowers in my front yard that were not yet dead until 4 or 2 days ago. And statistically, our first fall frost, according to the old climatology, was supposed to be, I think it's September 20th. And it's pretty common to sneak into early October, but early November? Of course, as we all know, 1 year is not climate, 1 year is weather. So we have to stay tuned and see what progresses in the future. But it's certainly an illustration of a graph like that. And this, some of you might know, Arnie Finklin was an old Forest Service climatologist at the Fire Lab. He sent me this compilation of records from all through the mountains of Montana and Idaho. So the same trend of progressive warming that I'm showing you for Missoula is repeated when you look at all the stations in the region. And of course, that's an important thing to look at. You don't want to draw any conclusions from one or two stations. This is one of the other figures that really spun me for a loop about a year ago. These came out. And this is the snow water equivalent in the snow-till stations in the mountains on April 1st. And all the red dots are a decrease, and you can see all through the Northwest a decrease of on the order of 40% in the snowpack on April 1st. Now, I grew up skiing out of Seattle, and I couldn't believe it last winter when Snoqualmie Pass ski areas were closed in January. I remember as a kid coming up there in our in the school buses. We didn't have any good bus. We were in the school bus, and we would pull up, and the snow would be above the top of the school bus, way above it. And last year they were closed in the dead of winter. So we're clearly seeing, and see, this all fits together. That warmer March temperature absolutely is consistent with melting the snow earlier, and these graphs show the hydrologic impact of those temperatures that I show you in the temperature data. So it fits. It's absolutely logical that these factors are telling us the same thing. Now this is the hurricanes for Montana that we should be concerned of. And this is for Canada. The correlation between area burned in wildfire and temperature trends for Canada for the last 80 years. This came out just about a year ago. And somewhere about 40 years ago, this trajectory of warming and accelerated fires started. I am looking intensely for any equivalent data for this for the U.S., because this is exactly what IPCC chapter is supposed to summarize. But if it isn't there, it isn't there. So far, I have seen a lot of pieces of evidence that haven't been fit together very clearly. I'm suspicious of this kind of trend, but I don't have the kind of evidence that would hold up to IPCC cross-examination, which is what our chapters get, is a cross-examination. For Canada, a very clear trend starting something like 40 years ago. Now, I lied. I said that I only had two model graphs. Here's one more model graph, because it is specifically for the Northwest by a group at the University of Washington that's probably done the most closely relevant forecasts for western Montana. And they're imagining as early as the 2020s another couple of degrees of temperature increase. A little bit more precipitation by the 2040s. 4 degrees increase Fahrenheit. That's pretty big. And that's not very far away. I'll bet the good majority of us in this audience expect to at least be here for the 2020s, we hope, and so we'll find out. So when I try to put this all together to a general summary, this is the sort of thing that I see we're already in the midst of. And I want to make that point. This isn't a projection for some distant future. This is a path we're already on, and we're really just looking at what the continuation will be. Shorter, milder winters with earlier snowmelt. Longer growing season. Decreasing summer stream flows. These summers when our trout streams dry up, we're probably going to have more of them. More drought and fire danger, and the biggest unknown that we have is how much precipitation the trajectory will provide. We know it's going to get warmer. If it gets warmer and wetter, we're going to kind of turn into, say, something like Eugene. If it gets warmer and drier, we're going to be something more like Salt Lake City. And so it's really going to make a difference to our local environment how much water comes with the warming. Some of the ecological impacts that I challenge especially the students, our grad students, to think about are some of these. Different agricultural timing. Very possibly, we really expect higher productivity. So there's a little bit of good news in all this. We'll probably get less deer and elk winter kill, but it could really screw up hibernation. This is another topic that I'm watching really carefully. We don't have the evidence yet that I think is clear, is whether we really have triggered an acceleration of big insect epidemics like mountain pine beetle outbreaks. We've had those periodically for decades. Is there any sense that climate change is accelerating that? We're suspicious, but I don't really see that we can prove it yet. I guess the last thing I want to say is that for the isolationists that think that we can just go on our merry way and forget about the rest of the world, this is NOx emissions. And you see that North America and Europe, for 30 years, we've really stabilized our basic NOx emission rate. And then you look at Asia. And in fact, I've had this graph in here for about a year, and I got this satellite image 2 days ago. This is a smog cloud over southeastern China that is probably here by about now. Literally, it's probably here by now. And so we have to negotiate with the whole world because we're downwind of some pretty serious emitters that if they perceive that we don't have any interest in doing anything, why should they? And we're in their tailpipe. I find it kind of interesting that this was the cover of National Geographic a year ago. And so when you forget about climate change and just start talking global economics, there's just book after book after book analyzing the world oil supply and demand. And basically, because of the explosion of demand, particularly out of Asia, and a peak in supply, they really think that we will look back in 10 years and say, looks like we peaked out around 2003 to 2005 in global oil production. And so we're going to have to fix that even if you didn't think of a thing about climate change. So the big question as a climate scientist we have, here's where the world's at, and this is another global mean temperature. And this is where we sat for 1,000 years. And this is where we've started. We've left the envelope of natural variability of the last 1,000 years. We're now beyond that. And the real question that we have, and what you guys have to solve next week, is are we going to end up here in the next 100 years, or can we slow this down enough to end up maybe something like here? I mean, this is the best we can do right there. But we could end up something like that. And it's hard for a global scientist to really fathom what the Earth system will be doing if we end up there. All right, so the end.
Well, maybe not quite the end, because here we have a chance for all of you, and me too, to get involved in this conversation.
Oh, do I get to sit down for a minute?
You could sit. Anybody want to start it off?
I've got a question. I've heard about like the ice age being like a major change in the climate, and like how like some people say that we shouldn't worry about this because of the ice age, and I'm wondering like if the changes like that happen like on these graphs, are they just so fast and so off the wall that you can't even compare it?
Well,
The question was, will the ice age cycle overtake this global warming? Something like that?
No, just like what do natural cycles in the past
Yeah.
say about whether or not this is human?
what natural cycles in the past give us probably the most significant evidence of, there's no doubt that the Earth's been warmer than this before. In the dinosaur era, it was warmer, right? So we've been warmer in the past. There's never been a climatic transition that they can detect that was anywhere near this fast. Recognize we're taking all the carbon that took 200 million years to be sequestered in oil and coal, and we're burning it in 200 years. So 200 million and 200. And so we're really imbalancing the basic stoichiometry of the biosphere just in the rapidity of what we're doing. And we really don't know what kind of result it's going to have. This has been called the grandest experiment of all. Except we don't have a control for our system. And we don't have anywhere to bail out if we decide the experiment's a failure, we can't go to Mars. Let me tell, well, we can go send people to Mars incidentally, but we can't get them back. And somebody should have told George Bush that, because you can't take enough fuel to Mars to get yourself back off the Martian gravity. So it's a one-way trip. That's right, we got a volunteer astronaut.
Question?
Yeah, I like Wally Grover's comment on the whole thing. The climate is an angry beast, and we are poking into the stick.
Yeah.
One of the things that seems to be a concern, and I don't think there's any real substantive conclusions one way or the other, but they seem to be concerned about hyperfluidity in both the Greenland and the Antarctic glaciers, that they're getting melt, and they're starting to see movement at a much greater rate. Do you have any new information on that? Because that one has pretty major implications.
Yeah. It was looking for a number of years, like of all the places that were not melting quickly, they thought Greenland was not. And then in just the last year or two, there's been some particular evidence of the acceleration of melting of the Greenland ice sheet. It's been a short enough period of time that I haven't read any real specific papers that give a long enough trend to know what to make of it. But certainly the last couple of years that's been noted. And when you see the whole rest of the cryosphere, how predominant the melt is of sea ice, the retreat is of mountain glaciers, the seasonal coverage of snowfall, you know, every single one of those metrics is showing a retreat. And so it's certainly expected that most likely Greenland will follow. The one thing that can happen is if you're in a really cold climate, if it warms up a little bit, you can actually get more snowfall, not less. Just like around here, our coldest nights are when it's really clear and dry. So you can have some confounding effects for a little while on those sort of mass balances of snow and ice?
Wondering what effects you think sort of modest reductions in our use of fossil fuels would have. Say, for example, the Kyoto Protocol, everybody fully goes for it, and goes back to whatever it was, 1990. What difference does that make? And sort of corollary, if we were to stop burning fossil fuels almost completely, what do you think the possible trajectories for this temperature, what would they be like?
Yeah, this is what makes this such an interesting political challenge, because I've had some of the best climate scientists answer that second question. What would happen if we went cold turkey and back to the caves tomorrow? And their best answer is we probably have 20 or 30 years of warming already in the ocean, even if we went cold turkey. And so that pretty much answers the first question, doesn't it? That the Kyoto Protocol is nothing more than a warm-up act towards anything that could actually matter. And I have to be honest that probably anything that humanity does to attempt to work on this in the next decade will probably be undetectable in my lifetime, no matter how hard we try. And yet, I'm not sure that we have any choice but to try, other than just cash in the whole experiment. But the hard truth is, the Earth system is a big, slow-rolling system, and I don't think anything we could do would change enough to be detectable for at least 20, 30, 40 years.
That's the best case scenario.
Yeah, that's right.
What's the worst culprit for the global warming in the world? Is it automobile exhaust, factories, or what is?
The biggest CO2 emitters, I'm almost certain of this, are the electrical power generating plants. I think, I'm almost certain of that. Particularly in the US and certainly in China. The biggest emitters overall are, Colstrip and all the equivalent around the country. They just put out unbelievable amounts of CO2.
So as we chug along towards higher temperatures and higher CO2 rates or concentrations, is there any consensus or convergence in current global climate models as to some threshold for any positive or negative feedbacks to kick in?
Yeah, you remember Tony Blair was pushing that conference just in Scotland about 5 months ago, 6 months ago, the Exeter conference it was called. And in their marching orders, a number of my friends were at that, and they said the day they got there, the politicians drilled into it. We want you to tell us what the dangerous level is. Just give us a number. Is it 450? Is it 600? Just tell us the number so we can get to work. Well, you can already see what the last 30, 40 years have done, and now we're only at 380. And in fact, Steve Schneider talked at this conference at Georgia Tech just 3 weeks ago on exactly this topic. And basically, the minute you say the word dangerous, you bring up social and cultural choices. That what's dangerous to one person may be perfectly harmless to another. And so right from the beginning, trying to define dangerous, you're not going to get very far. And then the second part of the problem, trying to define any certain threshold that where all of a sudden everything's going to unravel is the conference ended with the scientists refusing to do it. They said that just isn't the way this science operates, and we're just not going to play along with that It's a nice thing to ask, but it just doesn't add up in this kind of science, period. Yeah.
Steve, I have a question. I want to talk about rain. You mentioned rain at the talk at the church a few years ago. You said if it rains, we may be okay, and you had a lot of question marks after rain on this one. But in terms of the heating and the rain, I see a real interesting parallel between population at large and its rush to antioxidants over the last decade, and the increasing oxidative state fire that we see increasing by some percentage on the graph there as a result of, I guess, the planet heating up. So while we have the people of the planet doing this to the planet, we're also seeing the virtual destruction of brain tissue from oxidation, for one example, in the people that are doing this. But the rain question, that's a big one.
The rain question. Yeah. One of the things I find it kind of interesting, and I love to quiz my classes on this. I quiz them almost weekly, because when you do what I do for a living, I look at the weather report every night. And so I often I'll ask them at the start of the year, are we in a drought this year? And it seems like in Montana, everybody just assumes we're always in a drought. Is our annual precip this year ahead or behind average? We're about an inch ahead.
Long term.
And we ended last year ahead, and we ended the year before ahead, but then we had about 5 years where we were behind. But that's still weather, not climate. The bigger question that I finally isolated this problem. You notice whenever you read global warming statistics, they say the temperature increase is 1 or 2 degrees, and then they say the precip increase is something percent. What they never, ever tell you is the net water balance of that system has gotten wetter or gotten drier. Because remember, when it gets hotter, it evaporates more. So you can have a higher temperature and higher rainfall and end up drier.
Is that why the street flows are lower now, even though?
Well, what I'm convinced that nobody knows, and I'm going to present this in Seattle Monday, is that nobody has adequately put together the full water balance calculation to determine where on Earth it's getting wetter and where it's getting drier in a long-term trend. And I have one graph that I've made with some friends at NCAR. That's one calculation, but it's a real hard calculation to do, and I'm convinced we don't actually know. And I mean we, being the entire scientific community, because I got onto this about 8 months ago, and I've been grilling every one of my friends that ought to know the answer, and none of them know the answer any better than I know the answer. And so I think that's an unanswered part of this issue of whether precipitation is increasing rapidly enough to neutralize the higher temperatures from a point of view of water balance. Yeah.
Are there potential negative feedbacks or countervailing factors as the climate warms that might kick in and
Yeah, the one we hope for the most is increased cloud cover, because clouds, as we know when we fly around on airplanes, are nice and white on top, and so you get a lot of reflectivity off the top of clouds. And one of the things that there's a whole satellite program in place just to follow the changing trend in global cloud cover. Because if there is ever going to be a feedback that'll help us, that's probably the one that has the potential to be big enough to help.
Must need more airline travel.
Yeah, that's right, and more. You know, the part that gets really slippery in atmospheric chemistry is incredibly slippery, is if it's the wrong droplet size it turns out that it's not reflecting after all. And so a lot of aerosol chemistry is really wild stuff. And you got to have the right kind of aerosols, not just any old aerosols.
If we're at 380 right now, projecting out 30 years to your best case scenario, where does that put us in terms of?
And we're doing, let's see, what are we doing right now? We're doing 1.4 per year, I think about, so 20 years will get us over 400 anyway.
Repeat what that's about.
Oh, the atmospheric CO2 concentration, the background for the last few hundred years was about 280. We've now gone to 380. If I remember right, we're increasing about 1.4 parts per million per year. And so that'll get us to 400 parts per million within the next 20 years.
Why aren't the oceanic algae making greater use of this surplus CO2? And your data shows that the primary productivity is going down.
Yeah.
And that demands an explanation from you.
From me. My ocean, and you know darn well I don't know a thing about ocean plants. So this is a setup. I'm sure he planned this. Ocean productivity is more nutrient limited, is what they always tell me. It's more nutrient limited than it is temperature limited, or than it's CO2 limited, or that it's light limited. And so where you get the highest productivity is where you have upwelling of nutrients. That's what they tell me. And so it's a more nutrient limited system. You remember the experiment a couple years ago where they were going to sprinkle iron dust out in the ocean and accelerate the CO2 uptake? See, that was one of the efforts to see if enhancing nutrition of the ocean would enhance CO2 uptake. But they're not CO2 limited, is the start of the answers. So that ain't their problem, the way it is for land plants.
So if you're recording data from weather stations that are inside big cities versus random out wilderness areas,
It's called the urban heat island effect. And when one of my good friends is the director of the National Climate Data Center in Asheville, and he made his career on figuring out the urban heat island effect, Tom Carl. And so they've, long time ago, they've corrected the national statistics for that. You're absolutely right that on any given weather station, urbanization around it will heat up that local area. But there's also, because it's so well understood, it's easily corrected for in trying to compute these kind of trends.
Why is that caused? Why is that?
Why? Just because a parking lot absorbs almost all the incident solar radiation, whereas just about any other surface is going to reflect at least part of it. So as you add more and more pavement and buildings to a land surface, you're getting more and more heat absorption. And on top of that, then you have all the energy use of all the buildings to add to it. So you add both those together.
I read a little while ago about some ice cores that were taken in Greenland that showed some very dramatic changes in temperature over a short period of time. I don't remember what period of time is that.
Yeah, that is a topic that the paleoclimate folks really look at hard, is what is the potential, and this is back to Wally Broker poking the bear. What is the potential for really rapid climate change is the question they're trying to ask. This idea that, yeah, climate change is on 100 to 500 year sort of cycles in past history, is there any evidence that anything big could happen in just a few years? There certainly is when you add a particular perturbation like a major volcanic eruption. So let's take that off the table and say, is it possible for any other just very rapid temperature swing up or down? And they found some evidence of climate excursions of on the order of a couple of degrees in, boy, I'm trying to remember, pretty fast, like 20 or 30 years is what I remember. So they've got a bit of evidence that it's more possible than they thought it was 5 years ago. Can you answer that better?
Just, it seems that there's two studies, Severinghouse's work and Alley's work, both of which show a couple times where they had about 10 degrees centigrade changes in 10 to 30 years, they think, in the ice core records. So
10 degrees?
10 degrees.
Jeez. I didn't remember it that big.
And I
That's
think it was
big.
probably thermohaline is
Yeah.
they're thinking.
Yeah.
I've read that it's more likely to be the accumulation of small increases than, or just as likely to be the accumulation of small increases overall that creates the tipping point than a large event.
Well, there's lots of theories that people argue back and forth. When I go to my meetings, the more beer everybody has, the wilder the theories get, and I've heard that one too. And I've never heard any compelling evidence for or against it. So it's something that's absolutely is talked about a lot, but you don't see any consensus. And one of the things that our job is in IPCC writing is to not just lob every theory that comes along into the chapter. We have to wait until we're pretty convinced there's a consensus of people that know the topic, that yep, this is something that is widely acknowledged. Like the hurricane trends now, I think that's going to be in our report on January, which last April wouldn't have been.
Along with the effect on climate change and global warming, are there any projections or large-scale statistics on changes in atmospheric composition, the ratio, say, of carbon dioxide and other gases to oxygen as correlated with past climate change and species extinction?
There's obviously very active monitoring of changes in atmospheric composition. We talk about CO2, but they're following methane, nitrous oxide, help me out, carbon monoxide. There's a whole alphabet soup being followed of other constituents, some of which also have very strong greenhouse energy absorption characteristics. And so I don't want to suggest that CO2 is the only one that the science follows. And how that relates to, what was it, biodiversity and extinction?
Well, I probably listened to too much late night radio where they put on, the little green men and scientists who talk about global warming and things like that. But I have heard a rather interesting discussion on a past climate change where someone was proposing that there was a correlation between a drop in atmospheric oxygen and the disappearance of large animals. I would just drop that.
I know the oxygen content used to be way lower.
Yeah.
And,
yeah,
photosynthetic plants is what brought it up. I'm not a very good paleo guy, I'll confess. I spend most of my time thinking of previous 50 years and the next 50 years. So I'm not as good a person to ask paleo questions as probably a few of the other faculty that are here.
Well, Steve, but you are an ecologist, so let me ask a Gaia type question.
Oh, okay.
This is about how the living material on the Earth can fight back and make its own changes. There's a lot of talk about what's going to happen in the Arctic as the permafrost melts and the methane begins to release. How do you size that up?
Well, there's a couple of trajectories that we absolutely know are already happening. The first thing that happens in the high latitudes is the minute you replace snow that's highly reflective with mud that's highly absorptive, and then you've got a lot of more solar energy.
Sure.
Day in and day out is going to be absorbed by that surface. And so we've got an amplifier effect whenever we replace snow cover with bare soil or vegetation. Okay, once that surface is starting to heat up more and the permafrost is melting deeper, then, as you say, both methane and anaerobic systems and CO2 and aerobic systems are being emitted from those surfaces. The third thing that then might start happening is that with the longer growing seasons, there can be more photosynthetic uptake. So that would counteract a bit of the increased decomposition of the soil carbon. And so we have a carbon balance issue in the high latitudes that you've got a few arrows going opposite directions, and it all starts with this physical driver of warming temperatures causing this huge albedo shift from white snow to brown dirt. And we think that's going to overwhelm any photosynthetic enhancement, is our best guess right now.
Okay, and then with the 90% of the heat finding its way into the oceans,
Oh yeah.
what about the ocean current, the gyres, the Gulf Stream?
Yeah.
There are all these theories. Where is that?
Well, the most famous one was this character Wally Broker, who really is quite a character. And he's an absolute top-grade scientist, so he's not a quack one bit. But he kind of almost, he says he first started saying it as kind of a joke, and then enough people paid attention that he'd start thinking, gee, maybe it isn't such a joke. The thought that there could be a very rapid change in ocean currents, particularly of the North Atlantic conveyor belt, that is driven by temperature and salinity gradients from the high Arctic into the Atlantic. The Arctic Ocean has the smallest water mass per surrounding land mass. So that means you can reduce the salinity of the Arctic Ocean way faster than you can the Pacific Ocean. And so the way the theory, part of the theory at least was, geez, okay, all these ice caps and glaciers are going to melt in the high latitudes. They're going to freshen the Arctic Ocean enough that it's going to screw up the thermohaline circulation gradient. It'll shut down the North Atlantic conveyor belt, and Europe will get colder. And then this is where the suggestion that this could conceivably, it appears that there's paleo evidence that a flip-flop like this could happen in a matter of a decade or two if the right situation presented itself. Now, I've read papers just in the last few weeks that continue to analyze and say, we don't think that's really so possible. So that it's been around as an interesting theory for a decade or so. The current analysis is, number one, it hasn't started, and number two, it's the ocean circulation people aren't particularly expecting that it will. But of course, the hurricane people didn't expect the things that we just found out a month ago. So, none of this is, the uncertainty in this science is pretty large.
Let's take 2 or 3 more, and then I think Steve.
I have a question for you. You were mentioning a group called the United Nations Association.
Yes,
That's not to be confused with the United Nations.
Oh no!
What I've been reading is that the United Nations does not have climatic change on its agenda.
IPCC is sponsored by the United Nations in kind of a roundabout way, but our umbrella international authority starts with the United Nations.
In fact, the United Nations Environmental Program
UNEP.
and the United Nations Development Program are both up to here in dealing with these kind of questions and trying to figure them out and get the rest of us to do something.
Is there any correlation that you and your colleagues talked about between related climate changing and the climate involved, like with earthquakes, and if the atmosphere is warming up or the Earth's warming up, doesn't that mean all of the Earth is warming up? So
The interior of the Earth is already really hot. And so, no, I haven't heard any kind of theories like that at all.
Let's, how about here?
Any hopes that more organic farming is sequestering more atmospheric carbon?
Oh, yeah, that's a good one. The farming lobby is really big on that one.
Organic farming.
Well, the biggest gain to be made in farming practices is to reduce the use of the fossil fuels. It's not so much the accelerated sequestration of carbon, because that is a pretty temporary situation. And we've looked at that, we've poked at our models around and around, and it's kind of small. Every little bit helps, but it'd be a really little bit. The more important part of that equation is reducing the amount of just normal fossil fuel use for driving tractors around and plowing and things like that. But it's not so much the soil carbon sequestration itself.
Okay, way in the back. You.
I mean, faced with these fairly alarming trends, what do you think makes us do, like, personally, as a community and as a society? Let's think about this a lot.
Yeah, I think that we really, when you add up all this, we don't really have any choice but to get to getting to work on changing the entire trajectory of the global energy system. And that's why one of the things that it's I guess when you study this every day, you get kind of impatient, and yet I have to realize we're really trying to turn a very large ship, and it isn't going to turn very fast. And so probably we can, if we can just move into a future energy path, say 20 years earlier than we otherwise would, and cut the top off that top of the CO2 curves by say 100 ppm, then we probably should claim success. And yet we really don't have very much choice. If we really just say, oh, it isn't worth trying, we just might as well go for it. Well, when we start looking what go for it actually means, we could end up with a literally uninhabitable planet in another century or so.
What I was going to say is I've talked to quite a number of the scientists, the IPCC scientists in the last month or two, and I don't see any of them giving up. What I hear them saying is they're going to do their best, their damnedest, to shake us all so we realize that we've got to do something drastic and do it pretty fast. So stick around for the next couple of sessions. I don't think we'll get it finished quite, and then we'll get started. Last question. You.
You talked about the increasing amounts of tar and development, the strip malls, parking lots, that sort of thing.
Oh, yeah.
And we got a decrease in trees, cutting trees down. And then someone talked about the rapid shifts that can happen. I know, remember in chemistry class, you put a lot of a reagent in and nothing happened, and all of a sudden, bam, like the temperature gauge on your car, on a bad radiator, all of a sudden one day it takes off. So is it possible that this system could change with incredible speed that none of us anticipated?
that's certainly an issue that some of the climate theory folks try to explore is, are there non-linearities that really could rapidly change this system in a way that if it's imbalanced a little bit, it can change a little bit, and then all of a sudden, like a tippy canoe, all of a sudden it goes over. That's where some of these theories come from, and there's certainly a lot of discussion about it, but nobody can really go through a compelling illustration that it's imminent. It's a possible outcome, but I've never seen a good discussion that it's a likely outcome. We better hope so.
A breath of hope.
Yeah, that's right.
Maybe we should end on this upbeat note.
Yeah.
Thanks.